Next year we'll be doing P2 AQA Physics. That includes forces and motion. In force and motion we will be learning things such as the acceleration of an object is determined by the resultant force acting on the object and the mass of the object.
In P2 we will need to learn about the forces exerted when objects interact. These forces are opposite and equal. These forces may be replaced by a resultant force. A resultant force is a single force that replaces many acting on a certain force.
Next year we will be learning braking. This includes braking time, reaction time, and time for car to stop by friction.
In P2 we should understand terminal velocity. So as the instant of release, the katin accelerates under the action of its weight. As the katin's velocity increases, the drag force increases, and so the downward resulting force decreases. The katin then continues to fall at constant velocity. This is called the terminal velocity.
Next year we'll be learning about Hooke's law. This says that the amount of force added to an elastic object is directly proportional to the distance pulled. We will also learn that force applied to an elastic object, such as a spring, will result in the object stretching on and storing elastic fluid.
Do we still go?
Yeah, go.
Oh.
It's going to be in there now. Come on, keep going.
P2.2.
Momentum. P equals m times v. Momentum equals mass times velocity.
Momentum is found in all moving objects because all objects have a mass. Momentum always needs effort to stop.
Forces and their effect. A equals F divided by m, or acceleration equals resultant force divided by mass.
Acceleration. Something is accelerating when its velocity is changing. The bigger the change in the velocity, or the shorter the time it takes, the larger the acceleration.
Acceleration equals final velocity minus initial velocity over time taken, or A equals V minus U divided by T.
Physics. Are you ready?
In P2 we're going to need to learn about static electricity, the electricity produced when two objects rub against each other and become electrically charged. This is proven by the help of a Venn diagram.
And the graph.
Here are diagrams of circuit components. You will have to learn them to succeed in P.2.
Next year we will also need to know about the current through a component depending on resistance. We need to be able to explain the effect on current resistance has. Also we need to know about series circuits and the resistance around the circuit. Parallel circuits are also included and it's important to know about resistance in those too.
Next year we need to know the following things. The current through a diode flows in one direction only. The diode has a very high resistance in the reverse direction. The resistance of a light-dependent resistor decreases as light intensity increases, and the resistance of a thermistor decreases as the temperature increases.
Go.
This is how resistance is calculated. Resistance is the potential difference divided by the current.
Next year for P2.4 we are going to be using mains electricity safely and the power of electrical appliances. An experiment we could do to demonstrate this in year 10 is measuring relative phase between oscilloscope traces using the time difference method.
You should be able to calculate the period and frequency of an alternating current supply from an oscilloscope trace such as the one here.
Frequency. AC is the number of oscillations per second. You can find it from the period. Frequency equals 1 divided by 0.020 equals 50 Hertz.
Period of an AC supply is the time taken for one complete oscillation. You can find this by looking at the time between one peak and the next, between one trough and the next, or between any two identical places on adjacent oscillation.
Go.
What happens when radioactive substances decay and the uses and dangers of their emission?
Atomic structure. For this we need to know the basic structure of an atom, relative masses, electric charges, and how the atom has no overall electrical charge unless it gains or loses electrons, which makes it charged particles called ions. You also need to know about isotopes, atomic numbers and mass numbers.
You need to know, well you will know, some substances give out radiation from the nuclei of their atoms at all times. Whatever is done to them, these substances are said to be radioactive.
There are three types of nuclear radiation, alpha, beta and gamma.
Radiation can be absorbed by substances in its path. For example, alpha radiation travels only a few centimeters in air. Beta radiation travels tens of centimeters in air, while gamma radiation travels many meters.
Alpha radiation is the least penetrating. It can be stopped or absorbed by a person. Beta radiation can penetrate air and paper. It can be stopped by a thin sheet of aluminium. And gamma radiation is the most penetrating. Even small levels can penetrate air, paper or thin metal. High levels can only be stopped by centimetres of lead or many metres of concrete. If the radioactive source is in the body, perhaps after being swallowed or breathed in, alpha radiation is the most dangerous because it's most easily absorbed by cells. Beta and gamma radiation are not as dangerous because they are less likely to be absorbed by a cell and will usually just pass straight through the body.
Go.
Some guy invented the plum pudding model, which said electrons were embedded in positive jelly. This was wrong. You find out this is wrong and how Rutherford carried out an experiment to explain the real structure of an atom.
Next year we will learn about
nuclear fission. We will know that nuclear fission is a process where a large atomic nucleus is split into two parts that are radioactive.
We will also know that uranium must be 235 and plutonium 239.
Two or three more neutrons are released along with energy.
Nuclear fusion!
Nuclear fusion is one of the 6 topics that you will need to know for P2 by the end of year 10. The things you will need to know are:
What nuclear fission is? Fusion.
Stars release energy by nuclear fusion.
How stars are formed?
When a star is at its most balanced phase and why.
What the life cycle of a star is and how it is determined by its size.
How fusion in stars produces all naturally occurring elements.
You also need to know how the diagram above shows how stars are formed, and how the diagram below shows how nuclear fusion occurs.
Physics.